Let's learn a little bit about derivatives and what they mean in terms of the graph of the function. So here's a function f of x. It goes upward like this. It has a relative maximum, goes down, it has a relative minimum, and then goes back up. So when we're studying calculus, we have the function f of x, and the derivative tells us something about the graph. And it actually tells us whether the function is increasing or decreasing. So it's talking about a specific slope. So let's just say, for example, I have a point right here where you can draw a tangent line, and you can see that the slope of this tangent line is positive, and that's what the derivative tells us. It tells us the slope of this particular function at that point. So because it's positive, the function is increasing. And if we were over here, and if you were to draw a tangent line, the derivative is negative because it is decreasing. Well, what happens at a maximum or a minimum? If you have a maximum, you have a horizontal line right here. So the derivative at this specific point is going to be 0. And then the same thing's going to happen here. You have a horizontal line right here, and the derivative is going to be 0. And that's actually the whole point of critical points, is that whenever we take the derivative and set it equal to 0, we're trying to find the potential maximums and minimums. So let's just say, for example, you found when the derivative was equal to 0. You have two different points. Let's just call this A and let's call this B. So we know that f prime of A is equal to 0. We know that f prime of B is equal to 0. That's amazing. This tells us, hey, there's a relative minimum or there's a relative maximum at this particular function. We just don't know what it's gonna be. And that's where the second derivative comes in. That's how we answer that question you were asking, because the second derivative tells us concavity. So what's gonna happen here? Let's just say, for example, from here to here. Geez, I couldn't even see from the screen here, but basically what's going on here is the second derivative is negative because this particular function is concave down. I like to think of it, it's pointing this way. Think of it like you're frowning, you have a sad face. That's what concave down is. And then if we continue possibly from like here and onward, then the second derivative is gonna be positive because you think of, or you can think of it like a smiley face. So it's pointing upward in this particular direction. So that's why the second derivative tells us a lot about the critical point. Because look at this, we have a critical point of A, so the derivative is 0, and it's concave down. So the derivative here, the second derivative here is negative. So that tells me that you have a maximum. So when you have a critical point and the second derivative is negative at that particular point, you have a maximum. And in this particular case, kind of like the problem that we were talking about, the critical point at B has a second derivative that's greater than 0. In other words, that's positive. So it's concave up, therefore you have a minimum. And that's all you really need to know when it comes to the first and the second derivative and how they relate to possibly having a relative maximum and having a relative minimum.